Hello students, welcome to my channel Concept Tech 2018. I am Dr. Sunanda Manke and this video is a part of the series on online electronics laboratory, and in this part we'll discuss the lab exercises on combinational circuits. This slide gives the list of all the experiments which will be performed in this part. We have half adder and full adder circuit, 2x4 decoder, 1x4 demultiplexer, 4x1 multiplexer, 8x3 encoder and BCD to 7 segment decoder. So you can see here all the major combinational circuits are covered in this part. This is the trainer kit on which this experiment will be performed, and this is the general purpose kit on which this trainer kit is mounted. So DC supply from the kit will be connected to this trainer kit for operation of different ICs of the trainer kit. These are the input switches through which input will be applied to the trainer kit. Switches are having two position, high and low. So by changing the switch position, we can apply high input or low input to the given trainer kit. Let's see the details of this trainer kit. This trainer kit is having this 4x1 multiplexer. Then we have 1x4 demux IC here. Then we have 8x3 encoder IC here. And we have a BCD to 7 segment decoder here. And this is the LED driver. So all the outputs will be connected to this driver, and these LEDs are used to observe the output of all the given circuits. Let's do the experiment on 8x3 encoder circuit. The IC used for this experiment is 74LS148, and this gives the pin details or pin diagram of this IC. These are the 8 inputs and these are the 3 outputs. Being 8x3 encoder, it will have 8 inputs and it has 3 outputs. It's a 16 pin IC, so pin number 8 is ground, pin number 16 is power supply. This is the enable pin of the IC, which is active low. So when this pin goes low, only then this IC works. Two additional outputs are given here, E0 and GH. Let's see the working of this IC. So when EI goes low, this IC works as encoder IC, and it's a priority encoder IC. Why am I saying the priority encoder IC? Because the 7th pin is having the highest priority. When this signal goes low, this pin number 4, when this pin goes low, irrespective of the all other pins, all the outputs are low, because active low outputs are there, so all the outputs are low. Otherwise, in case of active high, all outputs will be high. So, and when this pin goes low and this pin is high, this is the combination output. When all the inputs are high and this pin is low, output is all high, right? So this 0th input is having lowest priority. So for this signal to work, all other pins should go high. Coming to these outputs, when this IC is not working, both are high, and when all the inputs are high, this is high and this is low. When the IC starts working, this goes low and this remains high. The working of encoder is, we observe one combination at the output for one active enable at the input, and priority encoder, if pin number 7 is low, irrespective of the values of the other inputs, output will be all lows. Input 7 is having highest priority and input 0 is having lowest priority. And you can observe here, this is the IC 74148 is used here. These are the 8 inputs where we'll connect the input through switches, the enable, and these 3 are the outputs. So we'll connect the outputs of this IC to the LEDs. The inputs to this IC will be given through these switches, and we'll do this experiment. Let's do it. This is 8x3 line encoder circuit. It's a priority encoder circuit. In this circuit, we have 8 inputs and 3 outputs. Outputs are connected to LEDs, and the 8 inputs are connected to switches, right? At any point of time, one of the switch will be enabled, its position will be changed, and accordingly output will change. Output is complemented, right? So the first value will be 1 1 1 instead of 0 0 0 when the first switch is enabled, right? It is 1 1 1. We'll start changing the position of individual switch and we'll observe the output, right? So it is 1 1 1, 1 1 0, 1 0 1, 1 0 0, next switch 0 1 1, next switch 0 1 0, 0 0 1, and it will be, last switch will be 0 0 0. All the LEDs are off because output is complement. So we have to observe the counting here. The counting shown is reverse. Let's start again. This is 1 1 1. Actually it is 0 0 0 being complemented. It is displaying 1 1 1, right? So LEDs are going, right? This is 1 1 1. The second switch, first switch 1 1 1, second switch 1 1 0, third switch 1 0 1, 1 0 0, 0 1 1, 0 1 0, 0 0 1, and last switch is 0 0 0. So for one switch position change, we get one combination at the output. This is how this circuit works. I hope you have enjoyed this experiment and understood the working of the given IC. Thank you.